Hello everyone. In this video, we are going to study the solubility of gas in liquids. So in daily life, we come across different type of gases that are dissolved in liquids. So you can take the example of oxygen, which has been dissolved in water. So whatever the aquatic life is present, it requires some dissolved oxygen for survival. So that makes the gases like oxygen soluble in water. And we can also come across carbonated drinks where there is carbon dioxide dissolved in that solution. So the solubility of gas in a liquid, this is a topic which is experienced in our day-to-day life. So if you consider a gas which is going to be dissolved in a liquid, see here, this blue colored one is a gas and the gray colored one is a solution. So there is a piston. Through a weight, that piston is made to move down or pressure is applied. So if you keep the temperature of the system constant and if you go on increasing its pressure, see the weight has been increased so that the pressure is increased. So as pressure is increased, more and more gas particles will be dissolved in this solution. The reason is, as the pressure is increased, if you see with the first and second picture, you can understand the number of particles, that is gaseous particles per unit volume, increases in the second case. So as the pressure is increased, you can see the volume is decreased. So here there is a larger volume, here there is a smaller volume. So as pressure is increased, volume is decreased. So that makes the number of gaseous particles per unit volume to be increased. So that will make the gaseous particle easier to be dissolved in this solution. So our conclusion is, as the pressure is increased, the solubility of the gas in any solution or any liquid goes on increasing. So this relationship was studied by a scientist called as Henry, and he gave a relationship through a law called as Henry's law. So this law states that at constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. So in the previous diagram you can understand, according to Henry's law, he states that at constant temperature, the temperature should be kept constant. The solubility of any gas in solution or liquid depends on the, or it is directly proportional to the partial pressure of the gas which is present above that solution. But it is seen that the solubility of any gas is equal to its mole fraction. So we can consider solubility of any gas that's equal to mole fraction, and mole fraction it's represented as X. So if this is the condition, the mathematical equation for Henry's law is given like this: P is equal to Kh into X. That means the partial pressure of that is directly proportional to solubility. Solubility in turn, it is represented by using mole fraction. So partial pressure of any gas is directly proportional to its mole fraction, and that proportionality, that is partial pressure, is directly proportional to mole fraction, and this proportionality is replaced by a constant represented as Kh, and this Kh, it is called as Henry law constant or Henry's constant. So this is the mathematical expression for Henry's law. P is equal to Kh into X, where P is the partial pressure of the gas in vapor phase and Kh is the Henry's law constant, X is the mole fraction of the gas. So it is seen that as Kh is increased, the solubility of the gas goes on decreasing. That means higher the value of Kh, lower is the solubility. To understand this, you can use this equation. So if I bring mole fraction to the denominator, I will get P by X is equal to Kh. That means as Kh is increased, the mole fraction is decreased. That means solubility also decreases. So higher the value of Kh, lower is the solubility or lower is the mole fraction value. And this was also understood by drawing a graph of partial pressure versus mole fraction. So they got a straight line. So this tells that the partial pressure of the gas goes on increasing, or it is directly proportional to the mole fraction of the gas. So that's about Henry's law. So we can study the importance of this Henry law constant. So it is a function of nature of the gas. So each gas has its own Henry's law constant, and based on that the solubility of that gas in particular liquid varies. So to study the solubility of any gas in particular liquid, we have to study the type or nature of that gas which is involved. And different gases have different kh values at the same temperature. So though the temperature of any system is kept constant, and if you are using different gases, each of the gases will be having different kh value, and based on that the solubility of these different gases changes. Higher the value of kh at a given pressure, the lower is the solubility of the gas in the liquid. This we have already studied. Higher the value of the kh, that is Henry's law constant, the solubility of the gas will be low. So that is about solubility of gas in any liquid. Thank you.